Hello and welcome to session 196 in the AISafety.com reading group. Tonight we'll be discussing the first half of the podcast, Ben Garfinkel on scrutinizing classical AI risk arguments by Ben Garfinkel, of course, together with Howie Lemble, Robert Wiblin, and Kieran Harris. Ben Garfinkel is a research fellow at the Future of Humanity Institute. And at 80,000 hours, we have Howie Lemble making the actual questions, as well as Robert Wiblin and Kieran Harris supporting. This is a podcast with this link here that also includes a transcript, and it was published on the 9th of July, but was recorded about a year ago. So some of the newest developments like GPT-3 are obviously not covered. We'll be discussing the first half, going up to the 1 hour and 43 minutes mark, mostly starting in earnest at the 50-minute mark. One thing I should point out in particular is that it's not precisely defined what constitutes the classic AI risk arguments. So I've chosen to mostly define that as the AI FOOM debate paper and the book Superintelligence. But whether that's entirely correct is a bit unclear. You could also argue that the classical period would be before 2015. But I would really like first to say a big thank you to Ben Garfinkel for making this podcast and doing the work that he's doing in trying to really look into whether the arguments that we have for AI safety are sound. I really strongly appreciate that. And also, where it is 1 hour and 43 minutes of podcast. So when I summarize this, I have to do that by removing qualifiers. So if Ben Garfinkel says something with a lot of, arguably A implies B, then I'll summarize it as he just claims that A implies B, and I'll give a counterexample, and I won't even include my qualifiers. I'll do that throughout, and that means it's kind of a strawmanish presentation, not of what Ben Garfinkel is actually saying, but what someone could say if they were making stronger statements in a way. Another thing is that Rob Wiblin claims that Ben has probably scrutinized classic AI risk arguments as careful as almost everyone else in the world. And one problem that I had when I made this presentation is that podcasts are not really the best medium for having a text where you need to engage very, very deeply with. A formal article can often be much better. And there were some times where I actually couldn't, there were some sentences I was unable to pass. And that's, of course, also problematic. There is a substantial reason that some of my objections here are based on misunderstandings. I think Ben would agree that it's really, really important that people write this kind of thing down. And if Rob says that Ben is the person in the world who is best positioned to do so, then I would really, really appreciate if this could be written down in a more formal way and more precise way. Right, let's get on with it. There is a general thought I had with this, and that is related to the counterfactual value of the classic AI risk arguments. So we ended the talk about Andrew Critch's arches with this quote: "The most useful form of pessimism is one that renders its own predictions invalid by preventing them." And here, of course, we have Nick Bostrom and Eliezer Yudkowsky making these kind of arguments. And this has indeed had an effect. And I believe that you can trace a direct line from Bostrom and Yudkowsky's argument to certainly OpenAI and quite a bit of DeepMind's work. And I think a lot of the insights we have into where is the state of the art of AI right now depends on these two organizations. And in particular, our epistemic state is also strongly influenced by organizations like Less Wrong, Future of Humanity Institute, MIRI, and their work. And so counterfactually, if we didn't have that, we would be in a situation where we had much, much less information publicly available. And that would, of course, also make things seem much less smooth. So in that way, there are two questions being mixed up somewhat here. Like, were the arguments correct when they were first written down, first made? And are the arguments still relevant? Because now we are actually doing something about AI safety, and do the original arguments still hold? And of course, that's what I'm going to focus mostly on here. So the podcast starts with a description of AI and AI risk, and why effective altruists would want to focus on this. And it's quite good. I really like it, actually. And I think it makes a great case that AI is important, neglected, and tractable. And he also seems very positive on AI safety more broadly. He points out that the case for AI safety has been broadened recently with some new arguments about political instability and login scenarios. I don't think they're really that new. I think you can find all of it in the book Superintelligence, but they're being given lower priority there. And it seems certainly much lower than what the effective altruism community assigns to it right now. Ben Garfinkel, however, returns to the classic arguments and the importance of understanding those and really digging hard against the weak points in those. In particular, among the classic arguments is the Bostrom-Yudkowsky arguments that have been written down in a very, very formal way, and those should probably be prioritized in vetting. And that's something that I really, really, really strongly agree with. I believe that figuring out this kind of skepticism is something that I've engaged very, very much with and very, very deeply. So one of the objections that people come up with is the one called painting a concrete risk scenario. And this is something that's not being done very much. And one thing that I noticed here was when I linked to the transcript on Facebook, and then Facebook added a picture to that that wasn't actually in the transcript. So I looked at where did that come from. It's a meta tag, and unfortunately, that indeed includes a very concrete risk scenario, a dystopian vision of how it could end up if we actually lose. To me, that was not safe for life, but I might be more emotional than most other people with that regard. So the argument here is that the descriptions of AI risk don't really seem grounded in reality, and I think most of them are not. I think Life 3.0 actually contains something that is quite detailed and seems quite grounded. And this, the argument goes, is not really true of pandemics or climate change. I'm not really sure. The descriptions of existential risks from global warming, in particular, the ones I've seen, don't really seem to be very grounded in reality and not very fleshed out at all, compared to the picture of like a moderate increase in global warming. So this seems like an odd thing, right? You have this huge existential risk, which you cannot really describe in concrete terms. And that seems odd, but we do actually have theoretical reasons why we should be unable to predict how this would go. And this is related to the singularity and the problems of figuring out what someone who is smarter than yourself would do. So much of the existing skepticism have a different focus, and that's that the original arguments don't engage with how AI research is today, because when we've had like the deep learning revolution from 2012 onwards, and AI was very different in 2008 during the AI FOOM debate. And so I think the book Superintelligence suffers a lot less from this than the AI FOOM debate, partly because it's newer. It seemed moderately agnostic towards what methods could be used to achieve AGI. And Bostrom is quite clear that machine learning is the most likely path to AGI. And so the thing we have seen mostly is that machine learning has improved far more than people expected, and whether the other approaches to AI are stagnating or if they are also improving towards AI, I think that's a good question, and it's really hard to say because all the focus is on machine learning because things are moving really fast there. Ben Garfinkel makes the following claim: I believe reinforcement learning techniques only get about 2 paragraphs in the book Superintelligence. So I looked that up, and I think this is kind of an example of the problem that I have with the fact that this is a podcast. Because if this was not a podcast where Ben have to make things up as he go, but if this was an article, then of course Ben would have looked this up and control F in the document and found all the 26 places where it says the word reinforcement, and he would see that sure there is a subsection called reinforcement learning with 1 page with 2 paragraphs, but after that there is a lot more about how to use reinforcement learning techniques for value learning, and it goes into quite a bit of details actually. And I think this here is the formula that Bostrom ends up with in the book Superintelligence. And I think it's fair to say that if Bostrom had gone substantially deeper into reinforcement learning theory than this, he would have lost, well, more than 99% of all readers, really. It's I don't think it's reasonable to expect Bostrom to go deeper into reinforcement learning than this level, basically. So apart from that, there is more to machine learning than reinforcement learning. So his history of AI emphasized in neural networks, and if you think that neural networks and reinforcement learning are reasonably related techniques, then I think it's not really that far from how you would write it in 2020. But of course, machine learning really took off in 2012, and I think the book was finished in fall 2013. So he just got the very start of a revolution there. And this might not matter really a lot, because the problem is that, sure, it doesn't engage that much with how much is actually machine learning, but this is an argument that never actually cashes out into anything. So you can't say use this as a reason for why some of the other things in the book Superintelligence is not true. And Ben Garfinkel is, of course, realizes that this is not a very good argument, but he is still sympathetic to people who react dismissively to AI safety arguments, in spite of the fact that the arguments don't really cash out into anything. I am substantially less sympathetic, right? If you have an argument that doesn't cash out into anything, then then it's just a poor argument, and the people who are working with AI are aware of this criticism and don't really engage with it. I think that's something you could criticize quite strongly. Another potential problem is one of the analogies for certainly the intelligence explosion is the evolution process, in particular the evolution of hominids. This is something that hasn't been written up very thoroughly yet. Ben says he's not aware of any more than a page-long piece of writing that uses this analogy to try to argue for the discontinuity. So the most obvious place where this is written is in the AI Foom debate, right? I try to count the number of times where we say chimp and hominid and evolution, and this is written like many places. But in a somewhat verbose and informal sense, trying to use this as an analogy, and thorough is not. The AI Foom debate is quite meandering. It's also something that's discussed over 4 pages in the book Superintelligence, and this also contains references to other people who have been working with this. But I think more importantly, the book Superintelligence argues that this is a rather weak analogy, and we probably can't use that for very much. I think this is the reason why I and many other people, we're busy people, right? And we we don't really have time to do a lot of work into something that we don't expect will lead to anything. And that's something that I think the podcast is. It would have been nice to have a bit more clarity here on that the evolution argument is actually not really in any way central to why we could fear a intelligence explosion. Another analogy that hasn't really been explored, according to Ben Garfinkel, is with how much compute does the human brain use? Like, could we get some timelines by looking at how much would it take to like emulate a human or something like that, and compare that with how much compute do we have right now? And this is something that actually I would say a lot of people have actually explored this really well. Notably, Robin Hanson in the book Age of M have written a lot about this. Unfortunately, from this, I'm not really very happy, because sure, you can get some lower bounds, and some lower bounds can be worthwhile, but they seem really weak, and I don't think this analogy is actually going to be very useful. Ben Garfinkel says that maybe the fact that the arguments haven't been written down is something that caused him to disregard them too much. And actually, no, I don't think that. I think it's quite fair to disvalue arguments that haven't been written down as carefully as, for instance, the book Superintelligence. But the book Superintelligence, in fact, has been written down in a way that is certainly sufficient. And that's why I believe that this is the key piece of writing you should focus on. Maybe focus even less on the AI Foom debate, for instance. So to get into one of the main points that Ben Garfinkel makes against the AI, the classic AI safety arguments, and that is what is called the brain in a box scenario, which is a specific AI development scenario that is purported to be implicitly implied in the classic AI risk arguments. And as you might be able to see from the screen, I think we are at the strawman fallacy here, in that this argument is actually not one that is central at all. It's almost not mentioned, and I had to go deep into these kind of old sources, the AI Foom debate, to try to figure out why this would be relevant and if anyone is actually using this. So the brain in the box scenario is that there is a time where we have some narrow AI progress, roughly like we're seeing now, but nothing that really transforms the world. And then, relatively abruptly, we have one AI system that is very cognitively similar to a human, to a brain. And from that, we get an intelligence explosion. That is my understanding of the brain in the box scenario. But I might be wrong here. And Ben Garfinkel, he describes this roughly with these words, but he doesn't make a reference to anything. He can't do that since it's a podcast and not an article. So I tried to see where I could find that, and I tried to Google for it. And the best thing I could find is the Foom debate, where after the actual exchange of blog posts, there was an in-person debate where Eliezer Yudkowsky described this, and he uses quite different words for the brain in the box scenario. There's nothing about that it will take between a day and a month. It will just take a while. And the thing that this brain in a box can do is reprogram itself, and whether it's cognitively similar to a human is not mentioned at all. Similarly, Nick Bostrom has a vision of an intelligence explosion that talks a lot about continuous improvement. It's not abrupt very much. This intelligence explosion, and the thing that the AI system is doing is improving itself, and it's not discussed at all whether it does anything else. One thing, however, that will be discussed later is the conception of deception. That one thing the AI system might do is to start to conceal its abilities. But apart from this, very cognitively similar to a human is not something that is described at all. So if I look, and Eliezer Yudkowsky is using this brain in a box, but Nick Bostrom is not. you could argue this, if you put the emphasis on brain in a box, then it sounds like the focus is that it's like a human brain. And I think another way to state this is the focus is that it's in a box. So if you put the emphasis there, then it's that it's not just a mathematical object, this AI model, and it's scalable. You can have 2 boxes, things like that. And I think the second interpretation of the words brain in a box is the ones that are used by Eliezer Yudkowsky. So is this discussed in superintelligence? Well, not really, and that's of course problematic if you are scrutinizing the classic AI risks arguments, that it's actually not included in the classical AI risk arguments. So there's nothing here that address the relative plausibility of something like the brain in a box scenario compared to something that is more smooth, or presents an argument why you would expect something like the brain in a box scenario. So part of it is clearly wrong, because the intelligence explosion parts, chapter 4 of the book Superintelligence is called The Kinetics of an Intelligence Explosion, and that is indeed precisely this. So the way that a single AI system undergoes an intelligence explosion is indeed described in very, 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 very great detail here. So I think that there is some kind of misunderstanding here, and Ben Garfinkel actually means something subtly different. If I should take a guess, one of the things that Ben Garfinkel might be putting a lot of weight on here is whether this what's sometimes called a seed AI, the AI that is able to improve itself but not really able to do much else, will it be able to do other things than that? Bostrom in the book Superintelligence, he doesn't really describe or doesn't care about this. But whether it might be, I think right now with GPT-2, for instance, it seems like these abilities actually are correlated to such an extent that it's quite reasonable to expect that it might be able to do poetry if it's capable of writing computer code. It's also possible that Ben Garfinkel doesn't mean this, but it's talking about an AI system even earlier than this, so before it can self-improve. In this case, talking about this very early stage, that's something that's described in the earlier chapters. You can find some of this in chapter 2.1 and parts of chapter 3, but I'm really guessing here, so I am quite unsure precisely what Ben Garfinkel means. So Howie Lemble tries to actually put things back on track and ask the question: assume that among the things that these narrow AIs are good at doing, one of them is programming AI, and so you end up with that level, leap to human level AGI, and then take off from here. So trying to focus these very broad cognitive things that a human can do into just the task of programming AI. And unfortunately, Ben Garfinkel dodges the question and instead talks about that if you're trying to do science, then there's actually a lot of different tasks in this. It's not just a single task. For instance, if you want to create new hardware, well, if you need to do that physically, then you need a very long list of skills. And that is undoubtedly true. But the thing Bostrom is worried about, and that Howie Lemble is asking about, is the simple task of actually programming the AI, in particular improving the AI itself. There is some talk about feedback around the human levels, whether the AI can outweigh the contributions to AI progress for all the other AI systems. Again, this very, very broad framing, like AI progress, is much broader than just improving a single program. And Ben Garfinkel believes that if it's able to do that, something interesting must have happened before. But if that does happen, then the risk is indeed substantial. I guess I could make an intuitive argument here that I can't prove or anything, but just about every program in the world can be improved with moderate effort. And from that reason, I believe that with moderate effort compared to the amount of work that went into actually creating the program. And from this claim, it seems quite clear that it is quite something we should expect, that the AI itself will be a program that can be improved. Another vision of the future is the comprehensive AI services modeled by Eric Drexler, where we see capabilities increase without increase in generality, and there maybe reasons why specialization might be favored over generality. And we might be able to see that in AI. In a different world, this might be something we see where something like GPT-3 doesn't happen, but apparently when you make a something that can predict text like GPT-3, then apparently it can do both poetry and SQL statements. And whether we are talking about something really general or specialized, in this case, what we really care about is the ability to improve one particular software program, and that is something that doesn't really require a lot of generality. Another thing that would be different in the comprehensive AI services scenario is that we'll be building narrower systems because of safety. And this is the original. The book Superintelligence doesn't really assume that the person who is building the seed AI that will undergo an intelligence explosion really care a lot about safety. So whether this is something that will actually happen remains to be seen. Ben Garfinkel probably believes that, or seems to believe that it's more likely that we'll have something very weird, a mix of things. And I think that's the future. Trying to predict the future is really hard, and the future is probably going to be weird in general. But we don't really care about the future in general. We care about whether this particular AI, the first one, which is capable of making an intelligence explosion, will actually do that. Another scenario is called the smooth expansion scenario, which is not really, it's hard to figure out precisely how much weight Ben Garfinkel takes to this, but that's that we slowly see an increase in how many relevant tasks the AI can do and how general the AIs are, what time horizons they are working on, how independent are they, and once we have the first system that can do everything a human can do, which is basically the prerequisite for this brain in a box scenario, then maybe they're already better at most things. That might be true, but in particular we care about the 6 cognitive superpowers in the book Superintelligence. Those are the ones that are strategically relevant, and the others are mostly not relevant. And of course, in particular, very, very concretely, we care about the AI improving itself. And Ben Garfinkel here has a statement that says the first system that can do everything a human can do might be preceded by superintelligent systems, and that's just wrong by definition of superintelligence. So if we are in a world where AI development is more smooth, then we might have a lot of other, this is a direct quote from the transcript, and I'm not 100% sure that I understand it correctly, but if we are in this smooth world, then where AI is improving gradually, then people are not so likely to be caught off guard, because we can do work ahead of time, and we can build institutions. We will know about the specific safety issues, in particular because we might have seen some of them before, things like specification gaming. We are seeing that already, and we might see more of those. And I think the specification gaming is probably quite likely something we're going to see more of, but in particular we're caring about the problem that's called the treacherous turn. I think Ben Garfinkel would return to this in the second half, but I'll just quickly say here that finding low-level versions of the treacherous turn, that seems really difficult, because to have that happen before we get software that's capable of improving a particular software program. And so there is some more discussion about whether capability improvement will be smooth in this way, and I believe that it could be smooth, and this conception of that the AI should try to hide its own intentions, that might be a candidate for a strong discontinuity in the safety landscape. Another model that is implied in the classic AI risk arguments is the race between capability and alignment. The argument goes something like this, according to Ben. And again, there are some of the sentences from the transcript that just doesn't make sense. So again, it's possible that I'm misunderstanding things here. But this model have a steady creep of AI capability increase year on year. And I think this is actually strongly not what the classical AI risk arguments say, because in those, AI capability doesn't increase gradually. It is, but we have an intelligence explosion. At the same time, the capability alignment race model have the AI goal progress, the alignment work basically, happening in a much more uncertain fashion. And this creates some kind of deadline in that if we get capability before we get alignment, then bad things happen. And we need to figure out what goals should the AI have before we have, as Ben calls it, extremely intelligent AI. And actually, as I read the classical AI risk arguments, we don't really care about the point extremely intelligent AI. We care about the point where the AGI is able to self-improve. Still, however, this deadline metaphor is one that is commonly used. It's just because people have a lot more uncertainty about how fast AI capability will increase. The deadline metaphor has a lot more uncertainty in the classic AI risk arguments. Now for one of the key points, the entanglement between capabilities and goals. Ben says, it would be hard to argue against the idea that there's a deep entanglement between advancing of goals and making AI act in a way we'd intuitively regard as intelligent. And, well, no, that would actually be really trivial to argue against. Because if we think about places where we see capability improve, we're thinking about things like where we have a benchmark, like chess, for instance. The goal in chess is to win. And in 1950, the goal in chess was to win. And in 2020, the goal of chess AIs is to win this game of chess, right? And if we have benchmarks, something like ELO ratings, then these benchmarks often imply that the goal is fixed. And if we have something where we also talk about capability improvements, like let's say image recognition, or all these kind of games that are commonly talked about when we talk about that AI improves, then in all of these examples, there is not any entanglement at all between the goals being advanced and the capability of the AI. They are completely disjoint. And even if we take some more general things like, let's say self-driving cars, for instance, right? Tesla probably, when they are programming their self-driving cars, then they probably do something, or they could do something like, let's say, the car should do like the average human would do, except outliers, and in particular except the outliers where the car crash into things. And they probably do something that's a bit more complex than that. But the real challenge of self-driving cars is in the capabilities. The real challenge is to have a model about what is going on around the car, to have an accurate and robust model of that. So Ben claims that making something more capable and the after project of making it have the right goals often seem really deeply intertwined. And it's not like it's two separate goals. And so selecting the right goals is an alignment problem, essentially. To me, these are quite different. If you try to make an AI working on the goals of an AI, then you're trying to say it should do this, and it should avoid doing this, etc. Where the alignment problem works in a much more indirect way, where we want the AI to, have a pointer to the humans, the masters of the AI, and say it should do what we want, and try to specify that in a robust way. And this is quite different. I'll argue for the disentanglement in two parts. The first is that even if we have a lot of progress on alignment, then that won't really help in capabilities. We won't get AGI just because someone comes up with a perfect solution to the alignment problem. Because if you take an AI right now, something that's implemented in Python or whatever, and then you say, oh, it should do what I want, and then the AI, it might try to do that, but it would obviously fail because we don't have the capability to make an AI that can look at a human and figure out what it is the human wants, even if we could do it safe. And a lot of the techniques that are used in AGI, they, like AI safety by debate, if you try to implement that with current AI capability methods, then that's obviously going to fail because we don't have AGI yet. The other example is with the example that Ben uses is with a house cleaning robot. And programming a house cleaning robot is pretty hard right now because it's hard to specify a goal. And I will argue that no, that's actually not the real reason why it's hard. But first, let's talk about narrow and general AI, because this is something that the classical AI risk arguments stress. And cleaning a house, is that something that can be done by narrow AI or general AI? One of the classic tests for whether something is an AGI is the coffee test by Steve Wozniacki, whether you can go into a random house and make a cup of coffee, and that seems strictly easier than actually going into a house and cleaning it. So this house cleaning robot is something we'll probably only have once we have AGI. And that's of course the reason why we don't have cleaning robots right now. Not particularly because we can't specify the goals, but because we don't have we can't make it do what we want. So Ben Garfinkel's vision of this house cleaning robot problem is that we could do it with some kind of reinforcement learning problem where we hand code the reward function. But if we make the reward function too simple, we'll get some side effects. It will ignore the things that are not there, and it's really hard to capture everything we want in a reward function. And I actually think it's going to be quite easy to do that. Not really easy, but compared to all the other challenges of a house cleaning robot, I expect this to be a really minor one. If you just say dust minimization, sure, that won't work. So you can't literally solve it in 5 seconds. But if you spend a day on it, then you can get much farther. And particularly, as long as the AI is narrow, then this kind of hand specification is probably going to work really well. So the major difference that I see here is that we need to just specify some approximate instrumental goals, like don't knock down the vase. And in the alignment problem, we're trying to precisely specify the final goals of the AI. And those things are really different. Yeah. And then Ben Garfinkel makes an argument that sure, this is a problem for AI safety, but AI safety is more, real housekeepers sometimes set the house on fire, and avoiding this kind of problem is something that's still relevant for AI safety. And I strongly agree, really. I believe that this is something which the classical arguments for AI safety make a big point about saying that this is not what they're about. This is not about ensuring that a self-driving car doesn't hit a pedestrian or something like that. This is not related to this at all. So in Ben Garfinkel's model, there is an unhappy valley that is required in order to have a disaster. And the first is that if there is no progress on alignment, well, then we won't use an AGI. If there's a lot of progress on alignment, well, then we will use the AGI, but that's of course also great because there's a lot, it will be aligned. But the unhappy valley is where we have enough progress on alignment that we can get capability, but not enough that it is actually safe. And my objection to this, I believe I've stated it a number of times, is that the framing is much too general. We're improving just one specific piece of software, and we might even have a fixed benchmark. Ben Garfinkel makes the following statement here that I think is quite likely to be false, and that is that only malicious or insane actors would make this kind of AGI pursue a narrow objective. And I think a narrow objective that can be specified really precisely is like a profit maximizer. You have a software program in order to make sure that we get as much money on this particular bank account while not breaking any applicable law or something like that. I think that's eminently plausible that we will get AGIs pursuing very, very narrow objectives. And also the fact that you say only insane actors would do this that seems unsafe. Well, I think the vast majority of AI researchers and AI users, they're not convinced about the merits of AI safety at all. And I think it's not just insane people who don't care about safety. A lot of really smart people are just basically plainly not convinced of the arguments. Finally, we get to the analogy of the strawberries on plates. According to Ben Garfinkel, Eliezer Yudkowsky have posed the following challenge. How do we get an extremely super intelligent system to move a strawberry to a plate without blowing up the world? And this kind of framing doesn't really conduct the way that machine learning research works. I'm not really sure what the word conducts mean in this particular thing, but I tried to look up whether this was actually something that was said. It's not in any of these classical things. The best place I could find was Eliezer Yudkowsky's Twitter, where he has pinned something that was very similar. Place upon this particular plate here 2 strawberries identical down to the cellular but not molecular level, which is I think that's quite different. But other people have used this analogy, and I found someone claimed that Eliezer Yudkowsky had said this, but had a dead link for the quote. So it's quite possible that he has at some point said this. But I think the key thing here is the framing doesn't relate very much to the way standard machine learning research works, and that is indeed on purpose, because the purpose of this strawberry on plates problem is to show that instructing a superintelligence is very, very different from what we're doing with our current machine learning, and this standard machine learning techniques cannot be assumed to help with this particular problem. That is all for the first half of Ben Garfinkel's podcast. Thank you for watching, and see you in 2 weeks.